Good day, everyone. So, we are about to discuss lessons from GE5 Science, Technology, and Society. Lessons from Chapter 3, specifically the Nano World. The Nano World. Topics includes what is nanotechnology? Ano nga ba itong nanotechnology? How do properties change at the nanoscale? Paano na-change ang properties kapag nasa nanoscale na? Various uses of nanotechnology, concerns on the use of nanotechnology, what are some careers related to nanotechnology? Ano yung mga careers na related dito sa nanotechnology? The status of the use of nanotechnology in the Philippines. Intro to Nano. Nanotechnology. What's the big deal? Importante ba itong nanotechnology? Bakit natin kailangang pag-aralan ito? What is nanotechnology? Nanotechnology involves manipulating matter at unprecedentedly small scales to create new or improved products that can be useful in a wide variety of ways. So, ang purpose pala nitong nanotechnology is mag-create ng bago or mag-improve ng mga products para magamit natin in different ways. Also, nanotechnology refers to the science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. Nanoscience and nanotechnology employs the study and application of exceptionally small things in other areas of science including materials science, engineering, physics, biology, and chemistry. Nanotechnology and nanoscience. The concept started in December 29, 1959, when physicist Richard Feynman discussed a method in which scientists can direct and control individual atoms and molecules in his talk. There's plenty of room at the bottom. During the American Physical Society meeting at the California Institute of Technology. How small is nano? Gaano ba talaga kaliit ang nano? Nanotechnology. Small, different, and new. Key ideas. First, the nanometer is extremely small. Second, at the nanometer scale, materials may behave differently. Third, we can harness this new behavior to make new technologies.
Why nano-education? Drawbacks? Not inherently interesting compared to dinosaurs. Below visible threshold, younger kids have problems visualizing and unexpected properties. Advantages: fun, breaks down disciplinary boundaries, cutting edge, relevant to future jobs and careers. An interdisciplinary endeavor means that interdisciplinary relating to more than one branch of knowledge, it is something involves two areas of learning, while endeavor try hard to do or achieve a goal. So this chart is the example of interdisciplinary endeavor. So the nanoscience and nanotechnology works because of the participations of these branches: the chemistry, biology, physics, engineering, medicine, biotechnology, material science, and information technology. So how nanoscience and nanotechnology importance, or why it is important? It is because the study of structures and materials on ultra small scale. So it improves existing industrial processes and materials and also applications by scaling them down to nanoscale. What is nano? So nano is came from Greek word dwarf, means extremely small. So nano is the use of matter on an atomic, molecular, and supramolecular scale for industrial purposes. So in this picture, you can see the prefixes for SI units, the symbol, prefix, meaning, and notation. Exa is the symbol of that is big letter E, and the meaning of that is 1 billion. So notation is 1.e plus 18. So 18, the 18 here is came from the 18 zeros here in the meaning, under the meaning. So that is why the notation is 1.e plus 18. So that notation came from the zeros here in the meaning. Kung ilan lahat yung zero na nandyan sa mga symbols is ganun din yung sa notation. Next, how big is nanometer? In the time it takes to read this sentence, your fingernails will have grown approximately 1 nanometer. So this is the picture of how nanometer is, how big nanometer is. So nanometer is a unit of measurement for length, just as you have with meters and centimeters. So it is a small. Another example of how big is nanometer is if you could paint the teaspoon of paint 1 nanometer thick, how much area would it cover? So, kung ilan yung na-cover, ganun din kalaki ang nanometer. So, merong formula for that. So, in the next, if you could paint a teaspoon of paint 1 nanometer thick, how much area would it cover? So this picture are also the examples. To cover a football field with a 1 nanometer thick layer of paint, you would need just a 1 teaspoon of paint. So example, divide the length value by 1e plus 6. That's how big a nanometer. So example, ang yung length is 1 nanometer and 1e 6 millimeters. So 1e plus 6 equals to 1 million because there is 6 zero in 1 million. Then the e depicts exponent of the base 10. And E is displayed by a scientific calculator when digits go beyond its screen. So in other words, the output shown in scientific is the notation.
Did scientists create nano? No, it was already in nature. Example of centimeters to micrometers, micrometers, nanometers. Smallness leads to new properties. Sometimes gravity loses. Similar to halftone printing. How to view nanomaterials? First, electron microscope. First developed by German engineers Ernst Ruska and Max Knoll in the 1930s, uses a particle beam of electrons to illuminate a specimen and create a highly magnified image. Electron microscope yield much greater resolution than the older light microscope. They can obtain magnification of up to 1 million times, while the best light microscope can magnify an image only about 1,500 times. Atomic force microscope or AFM gather information by filling the surface with a mechanical probe. George Bennig along with Calvin White and Christoph Gerber developed the first AFM in 1986. This microscope make use of tiny but exact movement to enable precise mechanical scanning. The scanning tunneling microscope or STM is among a number of instruments that allows scientists to view and manipulate nanoscale particles, atoms, and small molecules. Its development earned its inventor, Gerd Bennig and Henry Schroer, the Nobel Prize in Physics in 1986. Three types of special microscopes. Optical microscope. Optical microscope is also referred to as a light microscope. Is a type of microscope that commonly uses visible light and a system of lenses to generate magnified images of small objects. Scanning electron microscope. Scanning electron microscope is a type of electron microscope that produces images of a sample by scanning the surface with a focus beam of electrons. Transmission electron microscope that use a particle beam of electrons to visualize specimen and generate a highly magnified image. TEMs or transmission electron microscope can magnify object up to 2 million times in order to get a better idea of just how small that is. Think of how small a cell is. Types of special microscope example. Scanning electron microscope. Next, transmission electron microscope.
Nanotechnology, business and practical applications, where the Philippines is and where it should be. Here are some nanotechnology game changers. So we have nanotitanium, dioxide powder, 45 nanometer metal gate, silicon technology, cosmetics with nanoemulsions, experience silver nanotechnology. How small is a nanometer? So we have these things natural in nature. We have this dust mite, which is 200 micron, ant, which is 5 millimeter, human hair, which is 10 to 50 micron wide, fly ash, which is 10 to 20 micron, red blood cells with white blood cells, which is 2 to 5 micron, 10 nanometer diameter, which is the ATP synthase, the DNA, which is 2 to 1/2 nanometer diameter, atoms of silicon spacing tenths of nanometer, and we have these things that are man-made or yung mga tao ang gumawa, like just head of a pin, which is 1 to 2 millimeter, micro electromechanical device, which is 10 to 100 micron wide, red blood cells pollen grain, zone plate, X-ray lens, outermost ring spacing, which is 35 nanometer, nanotube electrode, nanotube transistors, quantern coral of 48 iron atoms on copper surface positioned one at a time with an STM tip, coral diameter, which is 14 nanometer, and carbon nanotube, which is 2 nanometer diameter. And this 21st century challenge combine nanoscale building blocks to make novel functioning device.
So, what is nanotechnology? The NNIUS defines nanotechnology as technology that meets the following three criteria. Nano size approx range 1 to 100 nanometers with properties and functions not present in larger dimensions. Design and control at the atomic molecular level and an eye vision, systematic control of matter on the nanoscale level that will lead to a revolution in technology and industry. Why should we be concerned about nanotechnology? So, nanotechnology is not a single technology. It may become pervasive. Nanotechnology seeks to produce a new materials with specific properties. It may also introduce new efficiencies and paradigms which may make some natural resources and current practices uncompetitive or obsolete. It may be very difficult to detect its presence unless one has the specialist tools of nanotechnology. So, do we have opportunities in nanotechnology? Yes, but we have to choose carefully. Nanotechnology includes materials and devices which range from the relatively inexpensive and accessible to the very expensive and inaccessible. Cost, benefit, and competitiveness, health and environmental risk, life cycle analysis.
Nanomanufacturing involves scaled up, reliable, and cost effective manufacturing of non scale materials, structures, devices, and systems. It also includes research, development, and integration of top down processes and increasingly complex bottom up or self assembly processes. In more simple terms, nanomanufacturing leads to the production of improved materials and new products. So, we have two basic approaches to nanomanufacturing. First is the top-down fabrication that reduces large pieces of materials all the way down to the nanoscale, like someone carving a model airplane out of a block of wood. This approach requires larger amounts of materials and can lead to waste if excess material is discarded. Second is the bottom-up approach to nanomanufacturing that creates product by building them up from atomic and molecular scale components, which can be time-consuming. Scientists are exploring the concept of placing certain molecular scale components together that will spontaneously self-assemble from the bottom up into ordered structures. So we have here a product of nanomanufacturing, and as we can see in the picture, it has a 16 gauge wire above that is approximately 1.3 millimeters in diameter. It is made from carbon nanotubes that were spun into thread. The same wire on a 150 ply spool below, courtesy of Nanocomp. Next is the roll-to-roll processing. It is a high-volume process to produce nanoscale devices on a roll of ultra-thin plastic or metal. Lastly is the self-assembly that describes the process in which a group of components come together to form an ordered structure without outside direction. Within the top-down and bottom-up categories of nanomanufacturing, there are a growing number of new processes that enable nanomanufacturing. And among these are chemical vapor deposition. It is a process in which chemicals react to produce a very pure high-performance films. And next is the molecular beam epitaxy is one method for depositing highly controlled thin films. We have also here the atomic layer epitaxy, and it is a process for depositing one atom thick layer on a surface. We have also here the deep pen lithography. It is a process in which the tip of an atomic force microscope is dipped into a chemical fluid and then it is used to write on a surface like an old-fashioned ink pen on the paper. Next is the nano imprint lithography. So it is a process for creating a nanoscale features by stamping or printing them into a surface. So, what's so special about the nanoscale? First, this scale at which much biology occurs. Second, scale at which quantum effects dominate properties of materials. And third, these nanoscale materials have far larger surface areas than similar masses of larger scale materials.
So the structures and properties of materials can be improved through these nanomanufacturing processes. So these nanomaterials, ginawa nilang stronger, lighter, more durable, water repellent, anti-reflective, self-cleaning, ultraviolet or infrared resistant, anti-fog, antimicrobial, scratch resistant, or electrically conductive among other traits. So the advantages of these properties in today, nanotechnology enable the products range from baseball bats and tennis rackets to catalyst for refining crude oil and ultra-sensitive detection and identifications of biological and chemical toxin. In nanoscale transistors may someday lead to computers that are faster, more powerful, and more energy efficient than those used today. So the nanotechnology also holds the potential to exponentially increase information storage capacity. So soon, ang mga computer daw, ang iyang entire memory will be able to be stored sa single tiny chip. So then the energy arena of nanotechnology will enable high efficiency, low cost batteries and solar cells. The next is the correlation between the top 10 applications of nanotechnology for developing countries and the UN Millennium Development Goals. So, the first is energy storage, production, and conversion. Second is agricultural productivity and enhancement. Third, water treatment remediation. Fourth, disease diagnosis and screening. Fifth, drug delivery systems. Next is the food processing and storage. Next is the air pollution and remediation. Then, construction. Ninth, health monitoring. And the last is the vector pest detection and control. So, for the government funding for nanotechnology in different countries noong 2005 by the RIT, for in the US is National Nanotechnology Initiative, the best known and the most funded program in the National Nanotechnology Initiative of the US. So the National Nanotechnology Initiative was established in 2001 to coordinate US federal nanotechnology R&D. So the NNI budget in 2008 and 2009 were $1.4 billion and $1.5 billion respectively. For the European Commission, ang European Commission, 2008 in February, the EC officially launched the European Nanoelectronics Initiative Advisory Council. For the Japan, Nanotechnology Research Institute under the National Institute for Advanced Industrial Science and Technology. For Taiwan, the Taiwan National Science and Technology Program for Nanoscience and Nanotechnology. India, Nanotechnology Research and Education Foundation. For the China, National Center for Nanoscience and Technology. Israel,
Israel National Nanotechnology Initiative. Australia, Australian Office of Nanotechnology. For Canada, National Institute for Nanotechnology. For the South Korea, Korean National Nanotechnology Initiative. For Thailand, National Nanotechnology Center. And for the Malaysia, National Malaysia Nanotechnology Initiatives.
Some concerns developing a rational and cost effective approach to nanotechnology. Patient situation. U.S. universities hold most of the patient uncertainties and abuses. U.S. Homeland Security restrictions, export controls, and sensitive technologies.
The possible application of nanotechnology in the Philippines. So first is the ICT and semiconductors. Nanotechnology has greatly contributed to major advances in computing and electronics, leading to faster, smaller, and more portable systems that can manage and store larger amounts of information. So second is the health and biomedical. So in health and biomedical, nanotechnology is already broadening the medical tools, knowledge, and therapies currently available to clinicians. Nanomedicine, the application of nanotechnology in medicine draws on the natural scale of biological phenomena to produce precise solution for disease prevention, diagnosis, and treatment. So next is energy. Nanotechnology is finding application in traditional energy sources and greatly enhancing alternative energy approaches to help meet the world's increasing energy demands. So in environment, nanotechnology could help met, meet the need for affordable, clean drinking water through rapid cause detection and treatment of impurities in water. So, in agriculture and food, in this field, nanobiosensors could be used to detect the presence of pathogens in food or nanocomposites to improve food production by increasing mechanical and thermal resistance and decreasing oxygen transfer in packaged products. So in health and environmental risk, nanotechnology, the science of the extreme small, holds enormous potential for health care, from delivering drugs more effectively, diagnosing disease more rapidly and sensitively, and delivering vaccines via aerosols and patches. Nanometrology. Next is education and public awareness. So in terms of this education public awareness, learning science through the context of nanotechnology application provides students with opportunity to learn how modern science works and the role that science and technology plays in finding solution to every life's problem. So, major environmental application of nanotechnology. First is the water treatment and purification. So, currently, nanotechnology plays a vital role in water purification techniques. Nanotechnology is the process of manipulating atoms on a nanoscale. In nanotechnology, nanomembranes are used with the purpose of softening the water and removal of contaminants such as physical, biological, and chemical contaminants. In environmental remediation, nanotechnology enables sensors and solutions are now able to detect and identify chemical or biological agent in the air and soil with much higher sensitivity than ever before. So in green nanocomposite, from saving raw materials, energy, and water to decreasing greenhouse gases and dangerous waste. Nanotechnology unique attribute can be utilized as various product procedure and application that could undoubtedly support environmental and climate protection. So, water treatment and purification. First siya sa major environmental application of nanotechnology. Nanoscale water filters can increase fresh water supply and protect water quality through effective water treatment. So, nanofiltration for clean water. Nanofiltration partially permeable membranes to perform the separation of non-filters have been applied to desalination and water treatment for removal of microbes and viruses and metals. So, the nanofiltration kay amo ni siyang nag-help para ma-clean ang water, which is para clean ang water para malayo sa sakit. So, dapat ang ginainom ta nga tubig is clean. So, that's why nagaano sang nanofiltration.
Number 2 is environmental remediation. So what is environmental remediation? It refers to reducing radiation exposure, for example, from contaminated soil, groundwater, or surface water. The purpose is more than just eliminating radiation sources. It is about protecting people and the environment against potential harmful effects from exposure to ionizing radiation. So, iron nanoparticles, it is a chlorinated compounds. Example of this is chlorinated solvents and pesticides and PCBs. So, there are compounds that are present in iron nanoparticles that is harmful in the environment. Because, as was discussed, there are compounds that are major environmental contaminants. The use of iron nanoparticles is for treating industrial sites contaminated with chlorinated organic compounds. It is also used in plastic, nanowires, coatings, and nanofibers and textiles. Nanoscale metal particles are central in buffering environmental systems, serving the dual role of limiting potentially toxic metal concentrations, while at the same time it provides a supply of metals at levels that enables a biochemical reaction to take place. So, nanoscale metal particles such as FeO and FeNi nanoparticles is in conjunction with iron filings. It has been shown to be a promising technology for reducing chlorinated compounds that is considered a major environmental contaminants. Next is titanium dioxide. So titanium dioxide is a semiconductor nanoparticles. These are one of a kind and important in promising photocatalysts. So, titanium dioxide nanoparticles have been used as homogeneous photocatalysts for the remediation of ground and wastewater because of their potential to degrade a wide range of organic and inorganic compounds. So, titanium dioxide is inexpensive and low toxicity. Titanium dioxide has been widely used as a photocatalyst. So in many environmental energy application because due to its efficient photoactivity. So titanium dioxide also has a high stability. At the same time, it is low cost. And the most important is it is safety to the environment and humans. Next is silver nanoparticles. So silver nanoparticles is has been long known to exhibit strong antimicrobial properties. So silver nanoparticles described frequently as silver because it is composed as a large percentage of silver oxide due to the large ratio of surface to bulk silver atoms. So silver nanoparticles has been enhanced with the discovery that the bacterial properties of silver nanoparticles is up to 1 to 100 millimeter or nanometer. are dependent on both their size and shape. So, it varies to the size and shapes. The use of silver nanoparticles is rapidly increasing because of its common application. Use of silver nanoparticles for antimicrobial coatings. And of course, many textiles, keyboards, and wound dressings. And also used in biomedical devices. So, silver nanoparticles continuously release a low level of silver ions to provide protections against bacteria. So, it is safe for us and beneficial for us humans. Number 3 is green nanocomposite. So, these materials with minimal impact on human health and environment improve performance. So, green nanocomposites is an eco-friendly polymers and environmentally sustainable and easily degradable. So, the nanocomposites based on eco-friendly polymers and eco-nanofillers are usually termed as green polymeric nanocomposites. So since green nanocomposites has a minimal effect to us human in our health, therefore it is healthy for us and safe for us to use green nanocomposite materials. At the same time, it provides convenience to us humans. Aside from that, the demand of nanotechnology is having huge impact on various consumer products. So nanofibers and nanoparticles are being used to create next generation non-woven materials and ultimately non-woven products for industrial and medical applications. So it has the nanotechnology has been rapidly increasing due to demand of the consumers. So the possible application of nanotechnology for the environment in the Philippines is passive nanomaterials. So these are the nanofilters and green materials. Next is the active nanomaterials, which is the photochemical reactors, antibacterial materials, and sensors. Lastly is the nano device, microlabs on a chip, and the self-reporting sensors. Benefits and application of nanotechnology. Nanotechnology is helping to considerably improve, even revolutionize many technology and industry sectors, information technology, homeland security, medicine, transportation, energy, food safety, and environmental science, and among many others. So, since we are taking Bachelor of Science in Nursing, so the benefit of nanotechnology in health and or allied health services is even today, various diseases like diabetes, cancer, Parkinson's disease, Alzheimer's disease, cardiovascular disease, and different kinds of serious inflammatory or infectious disease. So with the help of nanotechnology, we can prevent or diagnose early detection and prevention, improve diagnosis. Of course, proper treatment and follow-up of disease is possible. So, certain nanoscale particles are used as tags and labels. Biological can be performed quickly. The testing has become more sensitive and more flexible. So, through the help of nanotechnology, we future frontliners or future healthcare providers can provide accurate and efficient, effective healthcare services to our clients in the future. So it is, of course, it is convenient for us through the help of the nanotechnology. Next is benefits and concerns of the applications of nanotechnology in different areas. So examples of the areas affected by nanotechnology is environment, health, and economy. So the possible benefits of nanotechnologies in the environment is one is improved detection and removal of contaminants. Second is development of benign industrial processes and materials. So if there is possible benefits, surely there is also a risk or concern about this. So one of the concern is the high reactivity and toxicity. Second is the pervasive distribution in the environment. Lastly is the nano-specific EPA regulation. So in addition, EPA stands for Environmental Protection Agency. Next is health. So the possible benefit in health is, of course, improved medicine. So the concerns are ability to cross cell membranes and translocate in the body. Second is no FDA approval needed for cosmetics or supplements. Lastly is economy. So the possible benefits in economy is, of course, it provides better products and provides job opportunities or new jobs. So the concerns are redistribution of wealth, potential cost of cleanups, and healthcare. Lastly, accessibility to all income levels.
Social and ethical consideration in conducting research on nanotechnology. So the followings are the consideration in conduct before we conduct research on nanotechnology. So first, who will benefit from it? On the other hand, who won't? Second, for whom and what are your objectives for developing your product? Third, how will it affect social, economic, and political relationships? Fourth, what problem is your product trying to solve? Fifth, who will have access to it? Who will be included? Are there dangers involved with its development? For example, safety, health, and pollution? How can you minimize them? Seventh, who will own it? How can you assure access to it? In summary, nanotechnology is an advanced interdisciplinary field that encompasses science and technology that manufactures materials of great help to the improvement of various areas of society, especially healthcare, environment, energy, food, water, and agriculture. It is a field that needs to be explored, not only by known experts but also neophytes, in order to advance our knowledge of science and technology, and more importantly, to help improve our quality of life. But before we engage in nanotechnology, we need to take into account the social, ethical, and environmental concerns of using such nanomaterials.